Hello everyone, welcome back to this online class. Today we are going to look at finite difference tables. Now we have this question. We are asked to discuss the finite difference tables and hence work out the following questions. Number one, evaluate the polynomial f of x is equals to x cubed minus 8x squared minus 4x plus 1 for integer values between x is equals to 1 and x is equals to 10 and construct the finite difference table. Hence, use the difference table to evaluate the following. Part A, we have the forward difference raised to 6 of f of 4. Part B, we have the sixth order backward difference of f of 8. And part C, we have the sixth order central difference of f of 5. Number 2, the numbers -7, -6, and -1, 2, 21 are 5 consecutive entries in a certain quartic. Find the 2 entries preceding -7 and the 2 entries succeeding 21. And number 3, by constructing a difference table, find the 6th and 7th terms of the sequence 8, 23, 44, 71, 104, etc. So the question is, what is a finite difference table? That's the question. And why do we need a finite difference table? Take note that finite difference table what I can call FD tables, FD to mean finite difference. Finite difference tables are necessary they are useful when obtaining higher order, higher order differences. Let's say you want to obtain the 6th order forward difference of f naught, or even 6th order backward difference of f2. In that case, you see, it is easy to find the first order differences, but when we go to higher order differences, then the work becomes cumbersome, and so you will need the aid of finite difference tables to be able to simplify your work. I want us to consider this table. So you can write, consider the table, consider the row table of data for x and f of x values. So I'm going to draw it here. So let's say here we have x, and then we have the values of f of x. So that we can have x naught, f naught, x1, f1, x2, f2, x3, f3. You can have something like this one. Maybe I can extend to x4, f4, x4, f4. Let's use this. This is a table of data. It's not a finite difference table. Take note. This is a table. It's a row table of data which you have not analyzed. So remember, I also told you, you can also write a note here, that when I write fi, it simply means f of xi. The value of f when x is I. And in this case, I ranges from 0, 1, 2, 3, 4, etc. I is the indexing, the index. So once you're given that table, there are 4 types of finite difference tables. So you can write types of finite difference tables. I'll just use the right finite difference, which I'm calling FD. I'm going to be using the abbreviation FD tables. There are 4 types. The first one, or let me call it A, is the forward difference table. Let me use another color. You write forward difference table. Another one, part B, is part B, I can write the other side. Part B is the backward difference table. Part C is the central difference table. And lastly, part D is the divided difference table. Divided difference table. I'm going to show you how to construct these tables. And then once we know how to construct them, we look at those questions that have been given from number 1 all the way up to number 3. So let's start by constructing forward difference table. So write part A, we need to construct forward difference table. Forward difference table. So this is how you are going to construct it. We will have the values of x arranged in that column and the values of f of x arranged in the other column. Then a vertical line to separate those values. A horizontal line here. You can use a ruler. For my case, I don't have a ruler. So let me list those values. Here we have x naught, f of x, or simply f naught. Then you need to pass a space because we are going to write something between those spaces. Write x1. Here we'll have f1. Another space, then you write x2. Here we have f2. Another space, you write x3. Then here we have f3. And lastly, another space, x4, f4. So once you have something like that, I've got this line, I can redraw it. Let me just rub what I've done here, because I have a lot of space there. So let me redraw the line here. Something like that. Now, the first forward differences are denoted by this kind of a symbol. I told you this operator means forward difference operator. So when we write this means the first forward difference of f. Now, how do we get them? You take f1, of course, the next minus the previous, that's what we said. So here we'll have f1 minus f naught, that's what I'll write here. f1 minus f naught. Remember, you write in this corresponding to this space. This way you write it, those spaces. I'm just indicating so that you know those are spaces. They're not negative. So let me just rub so that it doesn't confuse us. Then again, take f2 minus f1, f2 minus f1, f3 minus f2, then f4 minus f3. So what is the interpretation? When we say f naught, f1 minus f naught, this is the same as This is the same as the forward difference of F naught. What about this other one? Is the forward difference of F1. This other one is the same as forward difference of F2. And this other one is the forward difference of F3. Remember how we defined forward difference? Forward difference of Fi is the same as Fi plus 1 minus Fi. That's how we defined our forward difference operating on Fi. So when you use the concept, you get what I've written in the first column of that table, of course, on the right hand side. Now we come back to now the second differences. So we get now we will write here delta squared of F operating on F. Again, you subtract. It is delta F1 minus delta F naught, or simply F2 minus F1, then minus F1 minus F naught. So it is the value here minus the value here. That's what you write in this space. Similarly, the value here minus this value here, you'll write it here. And also the value here minus this value, you write it in this space. I hope that is well explained. So let me rub those that I've written in black so that I can write the real figures, so the real values. So let's start with the first one. It is delta F1 minus delta F naught. So I'll write it here. Delta F1 minus delta F naught. Here we'll have delta F2 minus delta F1. Here we have delta F3 minus delta F2. What do we mean by when we write delta F1 minus delta F naught? This is the same as delta squared, delta squared F naught. This other one is the same as delta squared F1, and this other one is the same as delta squared F2. Third order differences, so I'll write here delta cubed F. So again, to get the value, we are going to start by saying this minus this. Then we write the answer here. This minus this. We write the answer here in that order. So let me rub those that I've written it back. And then write, here you are going to write delta squared F1 minus delta squared F naught. Here we have delta squared F2 minus delta squared F1. And so what is the interpretation of this one? It's the same as delta cubed F naught. And this other one is the same as delta cubed F1. And finally, we have the fourth order differences. Fourth order differences are right here. Delta raised to 4 operating on F. So you just subtract this minus this one, and then you write the answer in the space between them. So we'll have this as delta cubed F1 minus delta cubed F naught. And what is the interpretation of that one? It is the same as delta raised to 4 operating on F naught. Remember in the previous lecture, we were able to find delta squared of F naught, because you see, when I write delta squared F naught, it's the same as delta F1 minus delta F naught. It is F2 minus F1, then minus another F1 plus F naught, which is the same as, remember the value here For instance, this is the same as F2 minus 2F1, then plus F0. That's the value in terms of F. Again, here you can get it because it's this value minus this. So you can get it and write it here. But in terms of the interpretation, it is delta squared of F1. So let me just wrap that. Now, look at what we have here. Look at what we have. If you look at the F0 and even their differences, look at how they are sloping. I can see here, another F0 is here, another one, another. I'm tracking the F0 and even the differences. How are they sloping? They are sloping downwards. Let me change the color to even green so that I show you how to interpret this table. So if I draw a line like this, this is for the F0. They are sloping downwards. What about F1? They're also sloping downwards. What about F2? Downwards. F3? Downwards. So what it means here, we can write a note based on what I have written there. So I write a note here that the forward differences are read along a diagonal line. Are read along a diagonal line sloping downwards. Sloping downwards. That is all about the forward difference table. Let's look at the other table is the backward difference table. So part B, you write backward difference table. Again, you write X and f of X. Draw this line, horizontal, and a vertical line. So we can again populate this table. We'll have X0, F0, X1, F1, X2, F2, X3, F3, X4, F4. So again, let's get the differences. Now it is backward. Remember the backward difference operator. Backward difference operating on Fi. We said this is the same as Fi minus Fi minus 1. That's what we said. So now in terms of the backward differences, let's get those differences and fill them here. So let me change this color to blue. So first of all, we'll have the backward difference of F, the first order, I mean. So what do? We take F1 minus F0 as usual. F1 minus F0. The other one is F2 minus F1. The other one is F3 minus F2. And here we have F4 minus F3. So now what is the interpretation of what I've written there? Remember, when you are subtracting, you take the next minus the previous. But now the interpretation in terms of backward difference, backward difference. So this is the same as the backward difference, of course, first order of F1. In this case, I is equals to 1. Because when I put I1, I'm going to get F1 minus F0. When I put I2, you get F2 minus F1. So this backward difference of F2, in that order, this will be backward difference of F3. This other one will be backward difference of F4. So those are the first order backward differences. Let's go to the second order backward differences. What are we going to get? So you can write second order. Just like the way we are subtracting, it is this minus the other one. So the value here is backward of F2 minus backward difference of F1. Here it is backward of F3 minus backward of F2. Here it is backward of F4 minus backward of F3. So in terms of the interpretation again here, it is the second order backward difference of F2. This other one is the second order backward difference of F3. And this other one is the second order backward difference of F4. We proceed to the third order backward difference. When you subtract again, this is a second order backward difference of F3 minus second order backward difference of F2. Again here, second order backward difference of F4 minus second order backward difference of F3. And so in terms of the interpretation, this is the same as now the third order backward difference of F3. And this other one is the third order backward difference of F4. This one more. So the fourth order differences, when you subtract here, you're going to get fourth order backward difference of F4 minus the fourth order backward difference of F3. No, not fourth, those are the third order because it is this minus this. So let me change those powers. They should be cubed. I mean, there's a correction. So this should, because we are subtracting the values that we have already. So that when you interpret it, that's when it becomes the fourth order backward difference of F4. So look at the F0, F1, F2, F3, F4. Track them with their differences. I can show you with the another color just to explain how they are sloping. Let's start with F4. Look at the F4s. They are sloping in this manner. These are F4. F3, if you track them, this is what we get in this manner. F2 are sloping in this manner. F1 this way. So what do we realize? We realize that the backward differences are read along a diagonal line that is sloping upward. So we can write a note here, NB, and you say that the backward differences are read along a diagonal line sloping. So that one was, this is now sloping upward. That's all about aqua difference. I'll tell you how to apply these tables to be able to work out those questions that we have up there. Another table is the central difference table. So part C, you write central difference table. As usual, you write here x, then f of x, a horizontal line, a vertical line. Let us again populate this table. So we have x naught, here we have f naught, a space, then you write x1, here we have f1, another space, you write x2, f2, another space, you write x3, f3, you pass another space, then write x4, here we'll have f4. Do the subtraction. Now remember, we are talking of central differences, which we defined by the difference operator. The central difference operator is delta, the small delta. Operating on fi should be equal to fi plus 1 over 2 minus fi minus 1 over 2. So that's how we define the central difference operator operating on fi. So let's do the subtractions as usual, but now the interpretation is what will change. So here, when you subtract, of course, it will be the first order central difference of fi, not fi, but just f, first order central difference. This is f1 minus f naught, f2 minus f1, f3 minus f2, f4 minus f3. So now I want us to interpret that in terms of central difference. What will be our interpretation of those values that we have under the first order column? So here, look at this one. This is equals to delta of f. What do you think is the value of I? Because I plus 1 over 2 is equals to 1. So what is I? I will be 1 minus 1 over 2. That is 1 over 2. So this is 1 over 2. I hope that is clear. Because when I substitute I 1 over 2 in this definition, I am going to get delta of operating on f of substitute 1 over 2 is equals to f1 minus f naught, which we had here. This other one will be delta, because here now I should be I plus 1 over 2 is equals to 2. So I is equals to 2 minus 1 over 2, which is 3 over 2. So f, when you put I 3 over 2, you get that value. Here, delta f 5 over 2. This other one is delta f of 7 over 2. Those are the first order differences. So let's proceed to the second order differences. Now we are going to write delta squared operating on f. So as usual, you take this value minus this, what you get right here. Similarly, the other values you subtract in the same manner. So here we'll have delta f of 3 over 2 minus delta f 1 over 2. Here we have delta f 5 over 2 minus delta f3/2. Here we have delta f7/2 minus delta f, that is 5/2. So what is the interpretation in terms of the second order difference of this delta squared operating on f1? This other one is delta squared operating on f2. This other one is delta squared operating on f3. We proceed to the third order differences. Delta cubed operating on f. When you subtract again, this is delta squared operating on f2 minus delta squared operating on f1. Here we'll have delta squared operating on f3 minus delta squared operating on f2. And now the interpretation of this one is now delta cubed operating on f3/2. That is 3/2. So right here, 3/2. What about the other one? The other one will give you delta cubed operating on f5/2. So those are the third order differences. And lastly, we have the fourth order differences. So you'll write here delta raised to 4 operating on f, or simply the fourth order central difference of f. It is the same as delta cubed operating on f5/2. Let me write that as 5/2. Minus delta cubed operating on f3/2. And our interpretation for this one is the same as delta raised to 4 operating on f. That will be f. Is it f3? That will be f2. f2. So we are through with the subtractions. Now let's interpret these values, track those f and their differences. Like for instance, if I track f2, look at f2. f2 is this. f1 is this. Even f3 is this one. So what does it tell you? Because between f0 and f1, there's f1/2. f1/2 is here. There is also f5/2, which is here. There's f3/2, which when you track, you get it here. So those are horizontal lines. So when you want to read central differences, you read them along horizontal lines. So we can write a note here. So write NB. Under that note, you write the central differences. The central differences are read along a horizontal line. So notice the difference between central, backward, forward, and now part D will have the divided difference table. Look at how they are sloping. They are sloping differently. Lastly, we have divided difference table. So part D, we talk of divided divided. That should be divided. Difference table. You write here x, f of x. Horizontal line. A vertical line. So let's populate this table. We'll have x naught, f naught, x1, f1, x2, f2, x3, f3. Remember, you have to jump some spaces because we are going to write something in between the spaces. X4, f4. So divided difference operator, we are going to be using the D operator. The D. This is divided difference operator. So when I write df, it is now D. Remember, it's D. So do the subtraction. That's now this is how you're going to do it. It's different from the three tables that we have looked at so far. In this case now, you take f1 minus f naught, you write it here, f1 minus f naught, but again you divide by the value of this minus that. Remember, it is f1 minus f naught divided by x1 minus x naught. That's why we are calling it divided difference. So here we are going to divide by x1 minus x naught. That's where the name came from. Now the other one, do the same. F2 minus f1. We divide by x2 minus x1. x2 minus x1. Similarly, here we have f3 minus f2. Divide by x3 minus x2. You are dividing by the corresponding values of x. The one corresponding to f3 is x3. The one corresponding to f2 is x2. And finally, here we have f4 minus f3. That should be divided by x4 minus x3. So what is how do we denote this? It's denoted by f, then this kind of a bracket. That is, no, it's not a parenthesis, it's a closed bracket. Then here you write x naught, comma, x1. Use those closed brackets. That's the interpretation of that. Here we denote this by f, x1, x2. This one is the same as f, x2, x3. And this other one is the same as f, then the close bracket, x3, x4. That is 4. Let me write it in a better way. X4. Proceed to the second order differences. So we'll write here d squared f. How do you do the subtraction? It is this value minus this value, then over now x2 minus x naught. That's very important. So that's what I'll write here. I'll write here, let me use another color. I'll write here f, x1, x2 minus f, x naught, x1 But now we divide by x2 minus x0, the extremes, the difference between the extremes. Similarly here, it will be f x2, x3 minus f x1, x2. Then the difference between the extremes is x3 minus x1. The extreme values of x for that case, I mean. Here we'll have f x2, x3 minus f, no, it is f x, x3, x4, so I'll change those subscripts because it is the next minus the previous. This should be x3, x4. x3, x4 minus f, now it is x2, x3. Divided by x4 minus x2. And now the interpretation here is the same as f x0, x1, x2. This other one is the same as f x1, x2, x3. This other one is the same as f x2, x3, x4. So we proceed to the third order differences. So you write d, remember it is now d cubed f, d cubed. So you subtract in the same manner. Let me go up to third order differences because now you can complete with others. So here we'll have f of x1, x2, x3 minus f of x0, x1, x2. This one you divide by, the extremes is x3 minus x0. Similarly, here we'll have f x2, x3, x4 minus f x1, x2, x3. What are we dividing this with? It is the extremes, which is x4 minus x1. Now, what is the interpretation of this one? It is f, that close bracket, x0 all the way up to x3, x0, x1, x2, x3. This other one is f x1, x2, x3, x4. And you could proceed to the fourth order because you can see we still have another column that we can populate. But now you know what is going on. We can go all the way up to the fourth order divided differences. So that's all about the divided difference table and also those difference tables that you have discussed up there, central, backward, and forward differences. Now let's go back and answer the questions. Let me take you back to the questions now that we need to answer, now that we know the knowledge of difference tables. Let's now answer number one. We start with number one. Of course, I don't need to write it again. I'll just construct the table and then tell you how to be able to read those values from the table. So somebody might be wondering, why do we need to learn these difference tables? It is because we are going to use them when it comes to interpolation techniques. You need the knowledge of difference tables when dealing with interpolation techniques, which we are going to look at in the next lecture. So, question number 2. I'll write it here. That is question number 2. So let's start with question number 1. And so we are going to come up with the table of raw data. We need, remember, we are told that X should be from 1 all the way up to 10. So I'll write here. I'll write what we said between integer values, or simply for integer values between X is equals to 1 all the way up to 10, inclusive all the way up to 10. So come up with a table of raw data. We'll have the X values and the values of f of X, so that from there we can be able to construct our difference table. So let's have here, can have another color, maybe black. Let's have here X, and then here f of X. So we have that kind of a table. So when X is 1, what is f? The value of f of X, that you put X1, and so that will be 1 cubed. That is 1 minus 8 minus 4 plus 1. So the result there is negative 10. When X is 2, what is f of X? So where there is X, you substitute 2. Work it out. You can press that in your calculator. F of X will be negative 31. Do when X is 3. When X is 3, proceed the same manner. So when X is 3, what will be our f of X? That is negative 56. So I know you can now be able to populate that table. Go all the way to X is equals to 10. So once you have this table completed, let's now see how to construct the finite difference table. So as usual, we'll have X values here and the values of f of X in the other column. And then this horizontal line, a vertical line. So we are going to construct that table for all those values of X and f of X. So like X is 1, 2, all the way up to 10. Then you also list the values of f of X. So let me list them down. The values of X in one column, then the values of f of X in another column. So once you list down the values of X and f of X, this is what you should have. All of them, you see X going from 1 up to 10, and f of X is, the first was negative 10 and the last value was 161. So you list all of them. And now let's get the differences. So you just write here the first differences. Now you subtract negative 31 minus negative 10. It is negative 31 minus negative 10. So that's negative 31 plus 10, which is negative 21. So do the same. Negative 56 minus negative 31. That's the same as negative 56 plus 31. That should give you negative 25. You write it here. So again, negative 79 minus negative 56, what do you get? We are going to get negative 23. So proceed with the subtraction in that manner. Fill the remaining values under the first column. So under the first differences, these are the values that we have found. Once you subtract all of them, remember it is the next minus the previous. So do the same to fill the second differences column. So you write here second. That means the second differences column. I can use another color. Let me have it as red. So I'll have negative 25 minus negative 21. That's the same as, remember it is the same as negative 25 plus 21. And so that should give you negative 4. Also negative 23 minus negative 25, that's the same as negative 23 plus 25. That is positive 2. Also negative 15 minus negative 23, that's the same as negative 15 plus 23. And so that should give you 8. Remember, you write in the spaces in between. So complete the subtraction in the same manner to fill the remaining spaces under the second column. So that's what we have under the second difference column. Let's go to the third difference column. Remember, we are going all the way up to the sixth because what we need to evaluate are the sixth order differences. So we go to the third differences. Again, you subtract. I can now use another color. 2 minus negative 4. That's 2 plus 4, which is 6. You write it here. 8 minus 2, that is, again, 6. 14 minus 8, that's again is 6. 20 minus 14, 6. 20 minus 26 minus 20, that is again 6. We have 32 minus 26, that is 6. 38 minus 32, that is 6. So, look at the third column. Everything is 6. When you get to a constant value, you stop there because we are getting 6 throughout. What does it mean? That this is a polynomial of degree 3. It is a polynomial of degree 3. And so that's why you realize that when we get to the third column, everything is 6, a constant. So there's no need of proceeding with the subtraction because the rest will be zeros, 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 which you don't have to write. So once you have there, let me show you how to answer the questions. In fact, when we go to the question, let's go back to the question. What did we need to answer? We can go back to our questions and answer them. So just a minute. You see here, we were talking of the sixth order. We cannot get sixth order because our table is up to third order. And I told you once you get to a constant figure, you don't need to proceed. So let me just change the orders here and show you how to read them from the table. Here, I can just talk of the second order. I've changed this, let it be the second order. The second order. And here also, the second order. So not sixth order because we cannot be able to find order 6. So change them to order 2. That's a correction from the question. So how will we read those values? This is how we are going to do it. So in the first case, let me just wrap this line because it is too long, too large or long. Wrap it. I don't need it now because we have gone all the way up to third order. So we can answer the questions here. In part A of the questions, we want the second order forward difference of f of 4. So how do we get it? Look at look at 4. That means f when x is 4. When I write f of 4, the 4 here is the value of x. So locate 4 where there is x. So this is 4, and this value is the f of 4. This is f of 4. So I want the second order forward difference. I told you forward differences are read along a diagonal line sloping downwards. That's what we said. So let me use another color, then I show you how to slope. From here, we need to slope in this manner. Forward differences. So when you want the second order, you read the value under the second order. What is the value there? It is 14. So the answer here is equals to 14. Suppose you wanted the third order. Let me just add another question that was not there. Suppose I had said the third order of forward difference of F4, you will read the value under the third column, which is 6. Suppose you want just the first order forward difference of F4, you will read the value under the first column, that is negative 15. So I've just added those two so that you can get an idea of how we are reading those values. Then let's go to part B. Part B is now the backward difference. So again, we talk of the second order backward difference of f. In this case, it is f8. f8. I told you how to read the backward differences. Look at 8, locate 8. It is here, when x is 8. And so this value is the f of 8. This is f of 8. So backward difference, you need to slope upward. That's what we said, that you slope upward. So from this value, I'm going to slope in this manner. Let me draw it in a better way. I'm going to slope in this manner. So the values along that line. So because I need second order, I read the value under the second order column. And so the answer there is equals to 26. And you can read, if you want third order, it is easy to read, etc. What about part C? See, answering the questions are very easy. Once you have the table, it is easy to answer this question. Second order, central difference of 8, F5. So you need to locate 5, that is the value of x. So F5 is this value, which is negative 94. This value is F of 5, I mean. Central difference, how did we read them? We were reading them from, or simply they were sloping along a horizontal line. So from this value, you just go straight. Horizontal line. Read the value under the second order. The value again there is 14. You can see it there. Under the second order, this value. There's no value here under the first column. So when you are asked to find this one, the central difference of F5, that's the first order central difference. When you go to the first column, you see there's nothing. So you just say not available. When there's nothing, you say not available. Let me extend this so that I write available here, not available. If you read and you don't find a value, then you say it is not available. So we have answered question 1. Let us answer question 2. So you write question 2. I'll change the color to blue. And question 2, you can go up and check it, but already we know what it is. It is the sequence that we are given. We are given the sequence from -7 up to 21. Those are 5 consecutive entries in a certain quartic. -7, then we have -6, we have -1, we have 2, 21. We are told these are 5 consecutive entries in a certain quartic. The word quartic, what does it mean? This is simply a polynomial of degree 4. Of degree. That's what you mean by quartic. Quartic is a polynomial of degree 4. Cubic is a polynomial of degree 3. Quadratic is a polynomial of degree 2. So take note of those terminologies. So we are asked to find the entries succeeding 21 and the entries preceding -7. So I'm going to say let the entries preceding -7 to be A and B, A comma B, then -7, and here let it be C comma D. So I need to find the values of A, B, those are the entries preceding -7, and the values of C and D, those are the entries succeeding +21. So what you do here, you need to construct a difference table. So you see, these are values of f of x. We don't know x, but we know they have corresponding values of f of x. So you just have x and f of x. We are given the f of x values. X, you can just let them be x naught, x1, x2 in that order. So here you can just write x naught, x1. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll go all the way up to x8, x2, x2, x3, x4, x5, x6, x7, and x8. There are 9 entries that we need to populate here. The first one is what we don't know. I'll just call it A. The other one is B. The other one is -7. -7. Here we'll have, after -7, we have -6. After -6, we have -1. After that, we have 2, followed by 21, followed by AB. Then the other one was C and D, because we need to find the values of the missing or simply the unknowns. So once you have that, let's construct the difference table. So just write here first, as usual, subtract. It is B minus A. I'll write it here. b minus a. Here it is negative 7 minus b. Here it is negative 6 minus negative 7. That is 1. Here negative 1 minus negative 6. That is 5. 2 minus negative 1 is 3. Proceed in the same manner. 21 minus 2 is 19. This is c minus 21. This is d minus c. That's under the first column, the first differences, I mean. Let's get the second difference, because you see it is quatic. We'll go all the way up to the fourth differences. So second differences, what do we get? Work out negative 7 minus b, then subtract a b minus a. That would be negative 7 minus b minus another b plus a. So that would be negative 7 minus 2b plus a. What about here? 1 minus negative 7 minus b. So that's 1 plus 7 plus b. That is simply 8 plus b. 5 minus 1, that is 4. 3 minus 5 is negative 2. 19 minus 3 is 16. So we proceed in the same manner. C minus 21 minus 19, that is C minus. What is 19 plus 21? That is 40. D minus C minus another C minus 21. So that is D minus C minus C plus 21. So that would be D minus 2C plus 21. That's under the second order column. Let's go to third order differences. Again, we are going to take this value minus this. You write it, 8 plus b minus the whole of this, negative 7 minus 2b plus a. Remember, it's a minus of the whole of that. So it will be 8. This is what I mean, 8 plus b minus negative 7 minus 2b, it is 2b, then plus a. When you open the bracket, you get 8 plus 7, that is 15. So I'll write here 15. Then there's b plus 2b, that is the 3b. Then I can see minus a. You see the way I've done it? So proceed with the other values. Let me just wrap this one because now I don't need it. I don't need this. Proceed with the subtraction. I have 4 minus 8 minus b. So what do we have? 4 minus 8, that is a negative 4. Then minus b. Negative 2 minus 4, negative 6. 16 minus negative 2, that is 18. Do we have another value down here? Yes. C minus 40 minus 16, that is C minus 56. D minus 2C plus 21 minus C. That would be now plus 40. So that would be 61. Then minus 2C plus D. When you work it out. And lastly, because this polynomial was of degree 4, let's go to the fourth order. So you write here fourth. Again, do the subtraction. Negative 4 minus b, then minus 15 minus 3b plus a. Negative 4 minus 15, that will give us negative 19. Let me write in red color. So that was negative 19 Then we have negative b minus 3b, that is negative 4b. Then plus a, plus a. So we proceed with the subtraction and complete the remaining values. So now we have the finite difference table all the way up to the fourth differences. Now, because I told you this is a polynomial of degree 4, it means that the values under the fourth order column should be a constant, should be constant figures. So the values here, all these values that you see here, those ones should be constants. Let me bracket them. All these values, they should be constants. Now, what is the constant that you can see here? It means everything should be equal to 24. You look at what we did in the previous question. Because the polynomial here was of degree 3, look at the polynomial, it was of degree 3, and so you realize that the values under the third column were evaluating to a constant figure that was constant, which is 6 throughout. When your polynomial is of degree 4, it simply means that the values under the fourth column, the fourth order column, should be also a constant figure. And that constant in this case, I can see 24. So everything should be 24. So what we have here, we are now going to say that even negative 2 plus b should be equal to 24. So this should be equal to 24. Even this one should be equal to 24. Even this is equals to 24. This one is also equals to 24. So when you solve negative 2 plus b is equals to 24, what is b? From there we get, you can say this implies that our b is equals to, make b the subject, that is 26. Also, let's solve this. C minus 74 is equals to 24. So this means that our C is equals to 74 plus 24. That should give you 98. Let's solve this one. Negative 19 minus 4b minus 4b plus a is equals to 24. So what is the value of a in this case? It should be 24. I know b to be 26, so let me replace b by 26. Instead of b, I'm going to substitute 26 and make a the subject. So this, from here, it means a is equals to, I know this is something you can do. So that would be negative 19 minus 4 times 26. That is negative 123. When you take it to the right, it becomes positive. So when you add it to 24, what do we get? We are going to get 147. 147. We have added to 24. Because on the left it is negative 123. You take it to the right, you get positive 123, then plus 24. That will give you 147. And finally, let's solve this other one. 117 minus 3c plus d is equals to 24. So what is the value of d? Because I know the value of c to be 98. So where there is c, I'm going to substitute 98. 98. So from here you can now make d the subject. So that means I have 117 minus 3 times 98. That is still negative 117. When you take it to the right hand, no, that is negative 177. When you take it to the right, it becomes positive 177, then plus 24, you get 201. 201. So we have found the values preceding negative 7 and the values succeeding 21. Lastly, part C. Part C, we have a sequence of real numbers. In our sequence, what are the values in that sequence, or the terms? The values in the sequence called the terms of the sequence. And in that case, the first term is 8. The second term is 23, followed by 44, followed by, that is 71, and then followed by 104. So this is 71, then 104. 104. So I need the other two terms. 1, 2, 3, 4, 5. I need the sixth and the seventh terms of the sequence. So let the sixth term be A, and let the seventh term be B. Those are the terms I need. So what I'll do here, these are values of f of x. So we'll construct a table. Of course, the nth term is denoted by n. So this is u1, u2, u3, u4, u5, u6, u7. The nth term of a sequence is denoted by un to mean nth term of a sequence. Nth term of any sequence. So let's construct the table. So it's like these are the x values. The x values are just x0, x1, or simply the x values are the values of n from 1, 2, 3, 4, 5, 6, 7. So write n and then un. So the n denote the number of term. The first term, let me use another color. I can use black to populate those terms. Take this up to create some space here and extend this line. So we have the first term, that is 8. That's U1. Second term is 23. Third term is 44. The fourth term is 71. The fifth term is 104. The sixth term is A. And lastly, the seventh term is B. So let's populate this column. So the first column, the first differences, 23 minus 8, that is 16. Proceed with the subtraction so that you get the other values. Of course, it is 15, not 16. So let me change this. 23 minus 8 is 15, not 16. Take note. 44 minus 23. That should give you 21. So subtract 71 minus 44, that is 27. 104 minus 71 is 33. A minus 104, that is simply A minus 104. That should be 104. 104. And this is B minus A. Second difference is 21 minus 15, that should be 6. Let me write another color. This is 6. 27 minus 21 is 6. 33 minus 27 is 6. Then A minus 104 minus 33, that should be A minus 137. A minus 137. B minus A minus A minus 104, that is B minus 2A plus 104. We stop there. Why? Look at, I can see, we have some constant value, 6, 6, 6. So it means even the value here should be 6. And even the value here should be equal to 6. It is constant. We are getting constant values in the second difference column. So we can be able to solve these equations to get the values of A and B. So from here, let's solve this, the value of A in this equation. A minus 137 is equals to 6. So what is A? It is 6 plus 137. That is 143. So from here you get A is equals to 143. Now, once you know A, it is possible to get B when you substitute the value of A in this equation. B minus 2A. So B minus 2 times 143 plus 104 is equals to 6. So let me press that. Negative 2 times A, which is 143. Then I add to 104. That will give me negative 108. So B minus, no, it's negative 182. Sorry for that. Now we'll have B minus 182 is equals to 6. Take negative 182 to the right, you get positive 182. Then when you add to 6, you get positive 188. So you write here that the value of B is equals to 188. So we have found the 6th and the 7th terms of the sequence. So this is all about finite differences. Thank you all for watching this video. Please subscribe to my YouTube channel, that is Professor Francis Okech. When you go to the YouTube search, type Francis Okech or Prof. Francis Okech, and you will find me right there. Also, don't forget to comment, like, and share this video. When we meet next time, we'll look at more problems involving finite difference tables. Bye-bye.